Welcome to the second video about the flyweight pattern. In this video we're going to not actually implement the flyweight pattern, which I explained in the first video. We're just going to create the basis of actually creating the problem that the flyweight pattern actually fixes. So let's start by going into NetBeans. So let's go into NetBeans, and I'm going to create a new project. I'm going to create a JavaFX project with an fxml, and I'm going to call this one main. I'm going to call this flyweight example, and I'm going to click finish, and now we have a program that we can run. Let's test that it runs. Nice. So what I want to do now, I want to do something where I can draw on the screen. So I need a canvas and stuff like that. So I need to start changing my fxml file. I double click it, and then I remove this label here just by deleting it. I click on my anchor pane and I click layout, and I change that to width of 800 to the height of 600, and then I click the button and I say I want it to be 10 pixels from the bottom and 10 pixels from the right side, because this will place it all the way over here. Okay. Then I want to name my anchor pane. That's because I need to put something into the anchor pane. So I go to code and I name this main pane because it rhymes. That's it. So now I have my main pane and I'm ready to go. I'll save this and close this. So just for updating everything, I'll right click my fxml and make controller. This will give me the label. I can remove that. So now I have my anchor pane and my button. Remove this as well. So let's try to do some stuff here. So first off, what we need to do is we need to create a graphics element, and for that we have to first create a canvas. So first we're going to say canvas, and we want to import that, and certainly not the AWT but JavaFX canvas. Canvas equals new canvas, and we're going to set the width and height for the canvas. The width first was 800, and we're going to set the height, that I set that to 600, but I'm going to set it a bit smaller, sorry, 560, 40 pixels smaller, because that will make room for the buttons. Okay, so that's it. And then we can do something. We can write canvas get, and we need to find the graphics context 2D. Graphics context GC equals, and then of course we need to import the graphics context. The graphics context is the two-dimensional two-dimensional canvas that we can actually draw upon. So here I can say things like arch and draw images, stuff like that. So the next thing I want to do, I want whenever I click my my button, I want it to draw a ladybug. I can see I created the canvas up here. Actually I want to move it to the initializer. I want to create it immediately. I also want to put the canvas onto my main pane. So I say main pane get children, and then add the canvas. So what I think I'm going to do, I'm moving this, copying this up here so I can share it between the methods, and also the graphics context. I'm also moving that up here, and I'm then moving this and this, and I'm moving the instantiation. I'm going to do that on initialize instead. Oh, that was a bit too much. Like that. So now I have my graphic. So whenever I click the button, I can actually do something with the graphics context. So what I want to do is, first off, let's draw an image. So we can draw any image, and we can say I want to draw an image. I have to supply the image and then an x and a y value. Let's put it at 0.0, and then we should create an image to put there as well. So we write image, a new image, and then we need to put a URL, and I'm also going to put the requested width and height here. And the last two, this one is preserving the ratio. I'm going to set that to true, and the other one is smooth resizing, so it uses a bit more processing power, and that's good for this example. So let's do that. So here I have to put the path, so I'm going to call this ladybug.png, and I'm going to put image here. Of course this will not work because it can't find this ladybug. Let's try it. So when I click the button, it crashes saying cannot find a URL or resource. So I'm just going to find a ladybug image, and I know that I have a ladybug image right here, so I'm just going to copy that to my project. So I will just go to, first off, let's see where my project is. This is my source folder. So I open Explorer, I jump directly to that folder, and then I put my ladybug right in here in my source folder, like this. Let's see if that works. Wow, that's a big ladybug. So I also want to resize my ladybug. I want 3 different sizes of ladybugs, and I want 1000 of them on the screen. So how can I do that? I need some sort of loop, and I need to do draw them in a specific location. So whenever I create a new image like this, in this case I set the size to 0, so I think it actually just uses the original size. So if I set this to 20, it should resize it to approximately 20 by 20 pixels. Right? Very small one. So if we want to do a lot of different ladybugs in different sizes all over the place, I'm going to do a loop for doing that. So I'm just up here, I'm going to say 4, and I press tab, and I'm going to make, let's first start out making 1000 ladybugs, and if I do like this, it will draw all of them at the same place. So it will draw them in the upper left corner, 0.0, and then will be size 20. So let's put in some randomness. I'm going to say random rand. This will give us a random generator, and we can use this random generator to get some number. So the size, I want that to be either something like 15, or it could be 30 or 45. So how am I going to get 3 random numbers in these sizes? So I think I'm going to create a new method for that. So let's just go here, private, get random size, and I'm going to put the randomizer as a parameter here, so I can provide that. Okay, I'm going to return a random number, an integer, between 0 and 2. This will give me, this is probably, oh, I have to return an int here. This will give me a random number between either 1 or 0 or 1 or 2. But what I actually want, I want to map this into either the number 15, 30, or 45. So I could put an if sentence here saying that if this is 0, it's 15, if it's 1, it's 30, if it's 2, it's 45. Or I could do it mathematically, which is better, I think, in this case. It's easier to expand in the future. So first off, I'm thinking if I take these numbers here, and I multiply them by 15, I would not map them to this, but I would map them to something like 0, 15, and 30. So I could also say 3 here, then I would get 0 and 15 and 13 and 45. But as we already know, 0 would give us a giant ladybug. We don't want that. So we want these numbers to be from 1, 2, 3 instead. So the easiest way to get 1, 2, 3, if I add 1 here, now I will get the result 1, 2, and 3. If I put this into parentheses, now I have 1, 2, and 3, and I multiply by 15. Now I'm actually mapping my values from to 15, 30, and 45. Okay, so now I can use this. So I use get random size, and I need to put my randomizer there. And I'm going to use the same size for both of them. This will actually give me 2 different random sizes because it's saying next int. I want them to be the same, so I'm going to say size equals this, and then just reuse the size like this. Okay. So x and y size, width and height, I want that to be the same, so I don't want to run this twice. So now I'm creating 1000, but they're still being created at 0.0. So I can use this randomizer again, next int, to go from 0 to, for example, canvas get width and random of next int, and then again say canvas dot get height. And the problem is that the width and height of the canvas are doubles, so I'm going to typecast them into ints, so that that will just actually round them down to a whole number, which doesn't matter here. We just want an integer. It's just going to be inside of the canvas. So now I'm creating 1000 of these. Let's see how long that takes. Click, and let's see. Okay, so that took some time, right? And we have a lot of ladybugs here. So let's try to time that. Let's just use a simple way, system nano time. This will give us our time in nanoseconds. So let's save that as the start, and we have to use a long for that. Start equals the nano time, and then long end equals system nano time. So now we have the time it takes in nanoseconds. So let's just print to the screen. Time plus start minus end. Sorry, we have to take end minus start because the end is of course larger than start. And then we divide that by some number. Let's divide that by 1 million. And that should be, let's say so it should be milliseconds. Let's see here. How much time does it take? And everything is frozen. Yeah, so 6,000 milliseconds, or around 6 seconds. So that's something for 6 seconds for doing that. And you could probably imagine if I multiplied the size, or made 10,000 of these, it would take around 60 seconds. So this is very, very demanding. So before, this is the last part of this video. So before I go any further, let me say, what is it that actually takes all of this time? So for 1,000 times I run these three here. Actually, the draw image part isn't the hard one. It doesn't take that long to draw the image. One of the things that takes a lot of time is creating this image here and resizing it. This is expensive. So we take the original image and resize that, and we do it because we set true here. This was smooth resizing. So it all says here in the documentation that smooth indicates to use better quality filtering algorithm, or fast. So setting it to true, I'm not going fast, I'm going quality. So this is a very, very slow. So in the last video I'm going to show how to use the flyweight pattern to make this a lot faster, both faster and use less memory, because we only actually have 3 sizes of images. So if we can reuse this part here, then we don't need to recreate images all the time. Right now we have 1,000 images for 1,000 ladybugs. It's kind of stupid, right? So let's try to refactor this using the flyweight pattern, and this is going to be the last video.